is working. Well, should we get started?
Yeah, I think we can.
All right, take it away.
All right, hello everyone, and thank you for joining us for week 3 of the Concentrator Talk, brought to you by the Oxygen Alliance. My name is Mwabe Lungu. I'm currently in Lilongwe, Malawi. I'm pleased to be hosting the Concentrator Talk today. My colleagues Timothy Mtonga and Jerry Douglas are also joining me from Lilongwe. And we'll be here every week at the same time to answer your questions about concentrators and concentrator repairs. So remember that you can always send the questions by email to info@oxygenalliance.org, and we will do our best to respond during the concentrator talk sessions. So if you have a question that you'd like to ask right now, you can type them into the chat and we'll do our best to respond. So just a reminder to everyone, we ask you to keep your video turned off and your microphones muted unless you are talking. You are talking or asking a question. So again, with us on the call today answering questions are technicians. We have Paulina Mohosho joining us from Johannesburg, South Africa, Kowinda Singh from Chandigarh, India, and Georgie Kwanga and Mteto Sinjani joining us from Lilongwe also. So we have a slightly different format this week where we will have a topic of general interest, which is misuse of flow meters on oxygen concentrators. So that will come along as we proceed with our questions. So we'll also have a pause that we have introduced at the end of some of the questions. So please attend to them when they pop up. For those of you who don't know where to find the pause, if you go to the bottom right of your screen and expand the activities menu, you should be able to see the pause menu from there. So as usual, I will read out the questions and ask one of our technicians to respond. So we'll also paste the questions in the chat box in case you didn't hear them fully. All right, so we'll jump on to the questions now. So the first question says, we have received a donation of zeolite written 13X that could help us maintain the oxygen concentrators that we have. One of the concentrators have been giving out low oxygen purity, and we tried refilling the beds and they were not performing. And we tried putting them in a fully functioning concentrator of the same model, which is the Devil Base 525. So I will ask Mteto if you could please take up that question.
Okay, so as a refresher, or for those who may not be aware, zeolite is a chemical that is used in oxygen concentrators to remove nitrogen from room air, leaving the oxygen and few inert gases. So this process is called pressure swing adsorption. There are different types of zeolite, so be careful, as some types of zeolite might look physically the same, but they're different. There's sodium-based zeolite, also called 13X, which is the one you have. This type of zeolite is considered as low-price zeolite, and the performance is okay, but might not work in all models of concentrators, especially for those with high flow. The other type of zeolite is called lithium-based zeolite, also known as LIT. This is generally a more expensive type of zeolite and has higher absorption of nitrogen, leading to like better performance in comparison to the 13X you have. So with the model of the concentrator you're working on, the manufacturer uses lithium-based zeolite to achieve great results at maximum flow level. So despite having a pack of new 13X zeolite and following proper procedures that might not solve the problem of that concentrator. So in our experience, when using 13X in Devil Base 525, the highest purity that we were able to achieve at the flow rate of 5 liters per minute was around 87%. So for this one, if it's possible, please find the lithium-based zeolite that might solve the problem. Yeah, thank you.
All right. So I don't know if we have anything to add on. I'll ask the other technicians if you have something, then you can chip in.
No, that is the right answer, right?
All right. Thank you, Kuwinda. So Jerry, can you just open up our first poll, please?
All right, let's give this a try. So I've just launched the first question here. If you service concentrators, do you A, replace sieve beds, B, refill sieve beds, or C, both, depending on the model? So we'll give you about 20 seconds just to respond there, and then we'll show you the results. I hope you've all found the controls for responding.
I see we have a hand from Elena, or was that from Elia?
Seems we only have 2 responses so far, so we'll leave it open for another 10 seconds.
All right. So can we proceed as we wait for the polls?
Okay, I just closed the polls. Let me let me show the results here. So it looks like we've had 3 responses, and it seems it's mixed, both depending on the model. Thank you very much. Let's move on to the next question, please.
Thank you. All right, so the next question says, what is the correct and safest way to dispose of zeolite? So I will ask Paulina to take this one.
So the safest way to dispose the zeolite, so with the zeolite, so the disposal of the zeolite should be according to the local environmental health and safety and regulations. So you can either call an approved waste management company to dispose the zeolite. You will need an MSDS, which is a material safety data sheet, for them to determine the toxicity of the chemical, and also determine the landfill that they need to use to dispose the zeolite. Once the zeolite has been disposed, you will receive a certificate that confirms that your zeolite was disposed safely, and you can keep that in file for the authorities in case you will need it in future. And another option, if you do not want to use a management company, waste management company, you can directly contact the environmental authorities to get all the requirements that they will need from you to use an approved landfill to dispose the zeolite. So you will also need an MSDS for that, for them to determine which landfill you will need to use, and you will need to follow all the protocols that you will need to, all the safety protocols. So with the zeolite, you will have to avoid disposing it in drains, sewers, and waterways. So you need to avoid disposing it in those areas in case you might be in trouble with the environmental safety sectors. Thank you.
All right, thank you, Paulina. If we have anything to add on, I think you can always chip in. Okay, silence means nothing to add on. All right, so Jerry, can you please open up the second poll?
Thanks, Molly. So this question is actually not related to the question about zeolite disposition, but we would really like to understand the various roles of the people who are attending Concentrator Talk. So if you could tell us which best describes your role: biomedical technician / engineer, clinician, or other. We'll give you 20 seconds to get your votes in. Thank you.
Thank you. So just a reminder, maybe to those that joined us late. So for the pause, we have a pause option menu on the bottom right of your screen. So you don't actually have to type your answers in the chat box. But if you go on the bottom right, there is an activities menu. If you click on that, you should be able to see a pause menu, and then you can respond from that.
All right, I think we'll close the polls. So it looks like we've had 7 responses, 5 biomedical technicians / engineers, and 2 other. So it certainly seems like we've got the right audience here. Thank you.
Thank you. All right, moving on to the next question. I have an AirSafe Elite which is not working. When I switch it on, the compressor is not running. I have tested the power supply and the circuit breaker, and they are both okay. I've changed the temperature switch, and the compressor is not running. The model of compressor is Thomas 2660. When I remove the compressor, I noticed that the shaft cannot rotate. Can I apply oil lubricant so that it can rotate? Let me ask George to take this up.
Thank you for that question. While the different types of design of air compressor, the design that is used almost exclusively in all oxygen concentrators is called a double wobble. So with this design, you have 2 cylinders that are configured to compress air alternatively. That is to make sure that the load on the electric motor is shared evenly to reduce the power consumption. So the type used in oxygen concentrators are oil-free compressors, and these ones are designed in such a way that they do not use any lubricants in the compression chamber. This design is deliberate to avoid contamination of the medical oxygen because this regular oil lubrication is not allowed. It's not allowed in compressors that are used in oxygen concentrators. As we all know, oil is known to be a fire accelerant, and this may cause fire and when it's in contact with heat and oxygen. So I would advise that if you use special lubricants such as Zeolite TYN 142, those are special lubricants that can work well with oxygen concentrators. Thank you.
Thank you, George. If there's anything to add on from the fellow technicians, I think we can come in. And if we have questions from the audience, you can either paste them in the chat box or you can just raise your hands and then we'll attend to your question. If there's nothing to add on, Jerry, I think we can open up the 3rd poll.
Okay, thanks, Molly. So we'd like to know, if you have a failed compressor, are you more likely to replace the compressor or to try and repair it? So we have 4 votes in so far. Maybe we'll give you another 10 seconds. All right, I think we'll end the poll there with 6 votes, and hopefully you can see the results. So 1 person in favor of replacing the entire compressor, 5 people suggesting that they would try to repair it, and 1 person for both. I think we can move on. Thank you.
Thank you. So on to the next question. I have an oxygen concentrator that I was doing some weekly maintenance on, and I discovered that the intake filter is very dirty. There is no obvious way of opening the filter to change the paper, so I tried to blow the filter with compressed air just to see if it will get cleaned. But this made very little change. Unfortunately, I don't have access to replacement filters as of now, and ordering online will take longer for the filter to get here. So as I wait for the replacement filter, can I run the oxygen concentrator without an intake filter? I'll ask Kowinda to take this question, please.
Okay, thank you for the question. So the answer is no. The concentrator should not be used without the intake filter, because filter is a very important part in the system. So all the dust particles and humidity, they are separated by the filters. So every make and model of concentrator comes equipped with an intake filter. So there are 2 filters inside the machine. One is the cabinet filter, other is the fine filter or the HEPA filter. So they have their efficiency of filtering the air. So room air has a lot of floating around it, particles around it. Some are visible, some are not. So when some of these particles make their way through the concentrator, they can cause damage to some of the components within the concentrator. In order to trap particles of different sizes, filters are placed in certain areas within the concentrator, and the intake filter will go the intake side of the compressor. So its job is to trap the smaller dust particles that were not trapped by the HEPA filter. For this reason, it is advised to operate the machine, not to operate the machine without the it is advised to operate the machine without intake filter, especially when the environmental you are operating, it is very dusty, as a far amount of dust particle will still make its way through the HEPA filter. So the answer is no, it should not be used without the filter. Thank you.
Thank you, Kowinda. If we have anything to add on from the other technicians, please, the floor is open. All right, so if there is nothing to add on, Jerry, can you please open up the next poll?
All right, I've just launched the poll. So we'd like to know how available are replacement filters in your setting. We can get them when we need them. They're hard to get, or we've never managed to get them. So we have 3 votes in so far. We'll give you another 10 seconds. All right, I think we'll end the poll there. It looks like we've got 5 votes, and the majority of people are saying that they're very hard to get. So hopefully that's something that the Oxygen Alliance can help with in the future. Just a reminder, I guess, that we'd like people to keep their video turned off if you're not presenting. Thank you.
All right, thank you, Jerry. Moving on to the next question. What is the use of an hour meter? So I would like to ask Tato to take this one up.
Okay. So an hour meter is also referred to as a Hobbs meter. So Hobbs was the first company to make a meter like this. So it is So this is how it got that name. So oximeter were first used in aircraft to keep track of how many hours have been flown. So this information was used to schedule routine maintenance of the aircraft. An hour meter tracks down the number of hours the concentrator has been running. So for most old models of concentrators, the hour meter is analog, meaning the numbers move mechanically. And for new models, the meter is digital. While the digital version is cheaper, if there is a problem with the control board, the number of hours on the concentrator can be lost. Some of the components on the concentrator have to be changed depending on the number of hours the concentrator has been running. For instance, in a DevOps 525, the intake filter is supposed to be changed after 10,000 hours of running, or sooner if it is visibly dirty. So in summary, the hour meter is used to track how your concentrator has been run. Yeah, thank you.
Thank you, Mteto. If we have anything to add on, I think we can come in. All right, I think we are good here. So just a reminder for all of us that are joining us, if you haven't already given us your contact details, please just drop your contact details in the chat so we can add you to the mailing list and let us know what country you are joining from. All right, so we'll take a slight deviation from the questions, and then we'll move on to a brief explanation on the misuse of flow meters on oxygen concentrators. So over to you, Jerry.
Thanks, Maui. So one of the most common misconceptions we see is in regard to the use of flow meters in oxygen concentrators. Flow meters are used in hospital where they're typically plumbed oxygen, either coming from like a PSA plant or from an oxygen cylinder or possibly a cylinder manifold. And you can see an example in the picture here that shows a flow meter plugged into a wall outlet in the hospital setting. You can see at the zoomed in picture on the left, hopefully, that there's a calibration on here, and this one is calibrated to have a maximum rating of 15 liters per minute. So that's the most that you would expect to deliver to a patient using this particular flow meter. There have been studies that have shown that if you continue to turn that knob and you allow that ball to rise beyond 15 liters a minute, that you can get significantly more than 15 liters a minute. And from 4 different models of flow meters that were looked at, Noel, can we ask you to mute, please? Looking at 4 different models of flow meters, we actually found that the flow rates got as high as between 69 liters a minute and 74 liters a minute. So while this means there's potentially unnecessarily high use or consumption of oxygen, the purity of the oxygen that's coming from the flow meter doesn't change. It's unaffected. However, in the context of an oxygen concentrator, there's this direct relationship between the purity of the oxygen being produced and the flow rate. So specifically, as the flow rates exceed the maximum calibrated setting of the concentrator flow meter, which might be, for example, 5 liters a minute, the purity starts to degrade, it starts to fall off. So with the flow meter turned fully open on the concentrator, it might be that the purity of the oxygen drops as low as 50%. This, of course, varies from model to model. There's no sort of set standard on this. There is a secondary problem, which is that as we increase this flow rate, we're increasing the flow of air through the sieve beds, and that as we have these higher flow rates of air going through the sieve beds, it creates an accumulation essentially of moisture in the zeolite, which can also substantially reduce the life of the sieve beds. Our experiences in hospitals in Malawi is that clinical staff believe that higher flow rates are better for patients, and we frequently come across concentrators where the knob is fully open. So while this can be tackled through training of clinical staff, there is a relatively easy way to modify a concentrator to prevent the user from turning the flow meter above the maximum calibrated setting. So we achieve this using essentially a needle valve. We can see in the picture here, we're showing a couple or three different models of needle valve. They essentially have an inlet and an outlet. They can be considered bidirectional. There's no particular input or output. And by adjusting a knob, essentially, we're moving a needle up and down and changing the size of the aperture, which essentially controls the flow rate. So if we are going to think about how to address this problem of preventing users from using a flow rate from a concentrator flow reader that exceeds the maximum level, we can think about inserting one of these needle valves into the oxygen pathway before it gets to the patient outlet, essentially. And if we look at this classic schematic diagram of the concentrator, you're familiar with this from previous discussions. We have the oxygen product tank. We have a pressure regulator to get the pressure down to something comfortable for the patient. We typically have a filter there, a small bacterial filter, and then we go to the flow meter. It's very common to use 6 millimeter outside diameter hose that connects everything from the pressure regulator to the flow meter. And if we look back at the needle valve shown here previously, these have, particularly the one on the left, these have a 6 millimeter connection. So if we essentially cut the hose at the point between the bacterial filter and the flow meter, we can literally insert one of these needle valves in series. So as we do this, we of course need to adjust the needle valve to the right setting. So how do we do this? So the adjustment process is relatively straightforward. It starts by opening the needle valve fully on the valve itself to allow maximum flow through the valve itself. We then start the concentrator running, and we set the flow meter on the concentrator so that the ball is slightly above the maximum calibrated flow rate. So if it's a concentrator designed for 5 liters per minute, you might set the ball at 5.5 liters per minute or something above 5 liters per minute. Then gradually close the needle valve by turning it until the ball on the flow meter drops below where it currently is and drops down to that maximum flow rate of, say, 5 liters per minute. Finally, you just need to tighten the lock nut on the flow meter, on the needle valve. You can see in the picture here, the lock nut is a small nut with knurls on the outside that you just tighten with your finger, and that prevents the valve from basically changing its position. So you're locking it into that particular flow rate. Now, if you open the flow meter on the concentrator to the fully open position, you're going to observe that essentially the ball will not rise any further than the maximum calibrated position. So this is an important problem. It has clinical impact on patients if they're receiving low purity oxygen because the flow rate is exceeded above the maximum level. And this is a fairly inexpensive modification, but of course it should be done by a trained technician. So Maui, I'll pass it back to you. Thank you. I think you're muted, Maui, sorry.
Yeah, thank you, Jerry. Sorry about that. So I think if we have some questions from the audience, I think we can take them on before we proceed with the rest of the question. So you can just raise your hand if you have a question, or you can paste it in the chat box. All right, no questions. So I think we can proceed with the rest of the questions. So the next question says, what is the function of the blowdown muffler in the Millennium Respironics, and how does one know if they are faulty? I think we had this question from last session. So I'll ask George to take that one up.
To achieve pressure swing adsorption of nitrogen from the room air, the seabed in the concentrator alternate between the two modes. The first mode, known as the feed cycle, the air passes through the seabeds and the nitrogen is absorbed by the zeolite. In the second mode, known as the purging, the nitrogen that has been absorbed by the zeolite is evaporated from the seabed in preparation for the next feed cycle. This is referred to as a blowdown. So as the seabed is pressurized, the purging of the nitrogen makes a loud hissing sound. The concentrator are designed the amount of noise to produce. So when purging, as I said, the concentrator produces a hissing sound. So to achieve, to reduce the sound, some of the kind of silencer or a muffler, for example, in Millennium electronics, as in the question, the noise is reduced using this muffler. In electronics Millennium, the sound ranges from 40 decibels to somewhere around 9 decibels, depending on the model. So basically, to achieve that sound level, you're supposed to have some kind of mechanism to reduce that. To reduce that, as I said, the hissing sound when paging. So that's why they use this muffler. So basically, the main function of the blowdown muffler in this oxygen concentrator is to reduce that.
Are you done, George? I think we lost you in the middle there. All right, I think something happened there. So if we have something that we can add on from the other technicians, I would ask you to add in as we wait for George to come in, see if he had anything left. Yes, MT.
Yeah, just to add on. So I would say one of the symptoms that point out to a 40 blown down muffler is high pressure from the seabed. This is because the concentrator is not paging or the nitrogen gas through the exhaust. So this might affect oxygen purity. Yeah.
All right, thank you very much. I don't know if there's anything else that we can add on. So this question came from Augustus in our previous session. I don't know if he's here with us today. I was checking on the list. It appears he's not. So we'll now move on to the next poll. So Jerry, can you just fire that one up?
Absolutely. So have you ever encountered a problem with an oxygen concentrator where a blocked or clogged muffler was the cause? And keeping in mind that it's not just this particular brand that was discussed here, that most concentrators do have some form of muffler. Seeing two votes so far. I'll give you another 10 seconds on this, please. All right, I think I'll end the poll there. So we have 3 votes and 2 people saying they've seen it before, 1 person saying they haven't. So it seems like it is not an uncommon problem.
All right, thank you, Jerry. George, we lost you. I don't know if you had anything that you tried to explain before you lost connection.
I think I explained what I was supposed to explain. Thank you.
All right, thank you. Okay, so moving on to the next question. What is the purpose of the sieve bed check valve found in DevelBase 525 or 515? I'll ask Paulina to please take this one up.
Okay. The check valve, also known as the one-way valve, it's a valve that allows flow only in one direction. So in a DevelBase 525 and 511, we have the sieve beds check valve and also the final check valve. The final check valve, which is located between the bacteria filter and the oxygen outlet fitting, allows oxygen to flow out of the unit, and when it is turned off, it prevents water from the humidifier bottle to flow into the unit, while the sieve beds check valve prevents oxygen from flowing back into the sieve beds. So a sieve beds check valve can bring problems if they're not performing the way they were designed. For instance, the flow rate fluctuation, it can be caused by a faulty check valve. The low pressure in the product tank, which may cause low oxygen purity, can also be an indicator of a defective check valve. So those are the two valves that you can find just inside the DevelBase 525 and a 515, the one-way valves. Thank you, Mabi.
Thank you, Paulina. If you have any questions or comments from the audience and the other technicians, I think we can come up and add on to that. All right, so I think we will now move on to, all right, yes, George. I see there is a hand.
Yeah, I just wanted to add what Paulina is saying about one-way valves. In other models, like in AirSep, they have the same something similar to the check valve, but what they use they use is like the similar check valve, but in some cases they use the orifice. So just want to add that maybe some may say that is it only in the DevelBase 525 or 515, but they can also find in other models like in AirSep.
All right, thank you, George. Okay, so Jerry, can you please open up our next poll?
Thanks, Maui. So to what degree have check valve failures contributed to oxygen concentrator problems in your experience? Never, occasionally, or frequently?
So as we wait for the results for the polls, let me just remind people to submit their contact details so that we can add you to our mailing list. And please don't forget to let us know which country you are joining from.
Looks like we have got 3 votes here. Let me publish this. So occasionally and frequently. All right. Good to know. I think we can move on to the next question.
Thank you. So the next question says, how can I know that the control circuit board for AirSep Elite intensity 8 or 10 is not working properly? So I think we have our AirSep specialist, Kowinda. Can you please take this one up?
Yeah, so I will like to show the circuit board of this machine on video. So this is the circuit board used in the Elite or the intensity machines. No? It is nearly same. So for basically testing that machine is functioning fine. So here are 5 LEDs. So here they are. If you can see, 1, 2, 3, 4, 5. So center is the equalizer valve LED. If it is functioning properly, then that means the circuit board, valve, and the solenoid valve, that is okay. And one is the feed and one is the waste solenoid valve LED for side A and other is for the side B. So if all these 5 LEDs are working properly, that means the machine is working properly. So this is for the functioning of the circuit board and the solenoid valves. Correct? So now second thing. So here is one capacitor on this. If when we put on the machine, it will not work. It will sound like a choked one, or the short circuit will happen. Na? So then you have to check this capacitor. If it is blown off, then we can change this. So other 2 things are these are the like fuses, resistances used in the air sap, Zeolite and the intensity machine. So we have to check these also. So these are the basic failures in these machines: 2 resistors, 1 capacitor, and these 5 LEDs. If one LED is gone, then you can find out that solenoid valve or these 5 valves mounted on this, that is faulty. So this is the basic way to check the air sap, Zeolite or the intensity circuit board of air sap. Thank you.
Thank you very much, Kuwinda. If the other technicians have something to add on, please, you can come in. Yes, George. George, I think your mic is muted.
Yeah, just to add on that, there are some in the same AirSafe model circuit control board that you will not find the LEDs. So how do you, how are you able to know that this circuit board is not working properly? So what you do is you observe the sound of the relief valve on the compressor. That will tell you that something is wrong. Usually, when you just switch it on, you hear the popping sound from the relief valve. You can also check by using a voltmeter. So what we do is just check the voltages on the solenoid valve, because what is the operation is the circuit board, circuit board is supposed to supply a certain amount of voltage to the solenoid valve to operate. So when the voltage is not present across the solenoid, you can suspect that maybe the board is not okay. So there are different models, like maybe for 230, you need to test the voltage across the solenoid. So basically, for 230 models, the voltage across the solenoid valve is supposed to be around 200 volts, which is DC. And for those 110 models, you get about 100 volts, which is DC. So I just want to add that maybe you may come across other circuit boards that do not have the LEDs. So that's another way of troubleshooting. Thank you.
Thank you very much. All right, so to those just joining us, welcome to the Concentrator Talk. We do this every Thursday from 2 p.m. Central African Time. And please, if you want us to add you to our mailing list, you can drop your email in the chat box, and make sure to also specify the country you're joining from. So moving on to the next question. What is the purpose of the communication ports, such as the one found on the DeVille-based 525? I'll ask Paulina to please take this one up.
Thank you, Mabi. Okay, so the purpose of the communication serial ports in machines such as the RESP, Ronex, Everflow. So the purpose is to diagnose the machine. So these brands will have a software that you can run on a computer to do the diagnosis. So you would just need to connect the machine onto the computer, download the information through that serial port, and from that information, you will get the details about the estimated flow, the pressure, the oxygen purity, the temperature of the machine, also the previous alarms that the machines have, just to mention a few. Though there's no software available for the DeVilbiss 525, this port might probably do a similar job. Thank you.
Thank you, Paulina. I don't know if we have anything to add on. I'll ask the other technicians to come in if there's anything else. All right, so moving on, we also have another poll, and I'll ask Jerry to bring that one up, please.
Thanks, Molly. I've just launched it. So we'd like to know, do you have access to tools and software that can connect to communication ports on concentrators? All right, seems like we've got two responses here, and seems that the answer is no. So maybe this is an interesting thing to work on. Thanks.
Thank you, Jerry. So moving on to the next question. What is the function of the intake resonator in AirSep New Life? Can I run a concentrator without it? Let me ask Tedo to take this one up.
All right. So an intake resonator is found inside an oxygen concentrator, and it is connected to the intake of the compressor on one side, and on the other side, it is connected to an air intake filter. So it is there basically to reduce noise when the concentrator is pulling air from the surrounding area. So different models of concentrators have different types of intake resonators. I don't know if Jay, you can put a picture on an example of the intake resonator on the graphics. Yeah. So this one is like an example for an intake resonator for an AirSep. So normally it's like plastic on the enclosure, but you are going to find different resonators made from different materials. Like I remember from a Zeolite 515, it's made of metal. So yeah, but the function is the same. Thank you, Mal.
Thank you, MT. So if there is anything to add on from the other technicians, please do come in. And if we have no additional comments, let's move on to the next question. And I'll ask George to take this one up. I was working on a ZW280 compressor from a DeVilbiss 525 concentrator that was not running. I suspected the capacitor may be the cause, but I did not have a 10 UF capacitor to replace the original. So I used the 15 UF capacitor and the compressor is now running. Is it okay to use the 15 UF capacitor in place of the 10 UF?
Compressors that are used in concentrators are driven by asynchronous motors, also called induction motors, in which the current that is needed in the rotor to produce the rotation is gained from the magnetic field of the winding. This is the reason we need a long capacitor to create that magnetic field. If the long capacitor is installed, it will bring an even magnetic field around the rotor. As such, there can be an irregular rotation, which may result in more power consumption, and in some cases, an overheating of the motor. So, to answer the question, the capacitors is supposed to remain within the 5% of the original design value. I think Jerry can. Yes. So as you can see on the on the screen picture on the light, on the capacitor, it surely shows that the capacitor is supposed to be in the ranges of 5 plus minus 5%. So I would say I would not advise to use that 50 microfarad capacitor, but you're supposed to get something that is in the range of 5 plus minus 5%. Thank you.
Thank you, George. I don't know if there's anything to add on from the other technicians. Please do come in if you have something to add on. All right, I see no comments. So Jerry, can you please bring up our next poll, please?
Our last poll, thank you. So how frequently do you replace start run capacitors when repairing concentrators? Frequently, occasionally, or never? All right, let me end that one. It looks like we've had 4 votes, 1 frequently and 3 occasionally. Thank you.
Thank you very much. All right, so that was the end of the questions that we received this week. We got one question in the chat, but I think in the interest of time, we will tackle this question in our next session. So we have kept track of the question, and please don't worry that your question won't be answered. We'll tackle this one in our next session. So I would like to thank everyone for joining us today in our Concentrator Talk. Remember, we always meet every Thursday from 2 p.m. At the same time. We use the same link that you used to join the meeting. So the link will never change. So next week, same time, we'll also be here. For those that haven't sent us their emails yet and you want to be added to the mailing list, please send us your email address in the chat link, and then we'll add you to our mailing list. So thank you very much for joining us today. If there's anything from Jerry maybe that you need to add on, we will see you again in our next session.
Thanks, Molly, for hosting today, and we look forward next week to having Amarpreet back with us. Bye, everyone.
Bye.
Thank you.
Thank you very much. Oh, bye-bye.
Thank you.